Now let us learn about measures of dispersion. The measures of central tendency describes the central part of the given data to concentrate around a central value which is called as the average. But this measure do not reveal how these values are dispersed, spread or scattered on each side of the central value. Therefore, while describing a data set, it is equally important to know how far the item in the data are close around or scattered away from the measures of central tendency. The basic types of measures of measures of dispersions are range, quartile deviation, mean deviation, and standard deviation. Now let us learn about the range. A range is nothing else. It provides us the difference between the largest value in a data and the smallest value. That is, your range is given by L minus S. The coefficient of a range is given by the formula L minus S divided by L plus S, where L denotes the largest value and S denotes the smallest value. Now let us calculate the range for a given data. You consider the data 158, 164, 168, 170, 142, 160, 154, 174, 159 and 146. This is raw data. So the largest value will be, here it is 174 and the smallest value will be 142. So the range is equal to L minus S. So it is equal to 174 minus 142. It is equal to 32. Now the coefficient of range is given by L minus S divided by L plus S. It is equal to 32 divided by, it is 316, which is equal to 0.101. Now let us learn about the quartile deviation. Quartile deviation is given by the formula Q3 minus Q1 divided by 2, and the coefficient of quartile deviation is given by, it is Q3 minus Q1 divided by Q3 plus Q1. Now let us go for calculating a quartile deviation for a grouped continuous data. You consider the class interval 0 to 5, 5 to 10, then 10 to 15, 15 to 20, 20 to 25, 25 to 30, 30 to 35, 35 to 40 and 40 to 45. And corresponding frequencies are given by 3, 5, 8, 12, 34, 46, 28, 14 and 10. The sum of the frequencies are given by 160. Now for calculating the first quartile and third quartile, likewise in median, let us calculate the cumulative frequency. Start up with 3, then 3 plus 5 will provide us 8, then 8 plus 8 is 16, then 28, 62, 108, 136, 150 plus then 160. Now let us calculate the Q1. And Q1 is given by the formula. It is the lower limit of the first quartiles class plus n by 4 minus the cumulative frequency preceding that first quartile class divided by the corresponding frequency of the quartile class into the width of the class interval. And similarly, Q3 is given by the formula L3 plus 3 times, it is the third quartile, minus, it is M3 will be the preceding value of the third quartile's cumulative frequency. Then F3 is the corresponding frequency of the third quartile into the class width of. Now let us calculate n by 4. N by 4 is given by 160 divided by 4 is equal to 40, and 3n by 4 will be 120. Now let us fix the first quartile's class. Now n by 4 is 40. In the cumulative frequency, try to find the modal class which is having just greater than the cumulative frequency is 40. It will be 62. So the corresponding class will be the Q1 class. So here this 20 will be the L1 value, and the corresponding frequency will be the F1 value, and the value which precedes the Q1 class cumulative frequency is given by M1 value. Similarly, we find the class which is just greater than 120 in the cumulative frequency. The value which is just greater than 120 in the cumulative frequency is 136, and the corresponding class will be the Q3 class, and here this value 30 will be the L3 value, and 28 will be the F3 value, and the value which is just preceding the cumulative frequency of the Q3 class is 108, that will be the M3 value. So now we have got all the values. Let us substitute these values in the formula and we will calculate the Q1 and Q3 value. So your Q1 is equal to, it is 20 plus 40 minus 28 divided by 34, and the class width is 5, and Q1 value will be coming as 21.76, and your Q3 will be the lower class limit of Q3 class is 30 plus, it is 120 minus 108 divided by 28 into the class width is 5. So calculation provides us the value as 32.14. So now the quartile deviation value will be given by Q3 minus Q1 divided by 2. So that is nothing as 32.14 minus 21.76 divided by 2. The value is coming as 5.195. So this is the quartile deviation value, and the coefficient of quartile deviation is given by the formula Q3 minus Q1 divided by Q3 plus Q1. It will provide us 0.242.